5, correct? Okay. I mean, yeah, I did it in my head. It's 5. Yeah, easy. Okay. What we need to recognize on this one is there's a couple bits of information here. The first bit of information is if I have a center angle, the arc it subtends, or it cuts, is going to be the same measure as that. So because that is 90 degrees, that means that this whole thing, this whole arc is now 90 degrees. And what we also have to recognize is if my chords are congruent, that means the arc they subtend is also congruent. So if this is congruent to that, that means this arc is congruent to that. So that means I'm just going to take 90, divide by 2, and it's going to give me the old 45. Good? Okay, and what I forgot to do over the weekend is I forgot to post the solution key. I had the answer key that just had the answers, but I never posted the solution. Hopefully no one's looking for it because no one asked me for it. I will post it tonight. But before we get to that, let's just talk about questions from the homework. And I'm not going to do the whole problem. I'm just going to set it up and let you finish it. So questions from the homework. Yeah? Is that 28 or 29? 28, okay. We didn't even have a 29, did we? All right, 28 says X, Y, and Z are points on circle P. My circle apparently doesn't show up. Such that triangle XYZ is equilateral. So all they're saying is take a circle, put an equilateral triangle inside of that guy. We'll do our best we can. That doesn't look equilateral at all. We'll just do what we can. We'll say that's equilateral. So this length is equal to that length is equal to that length. And we have a center. Let's say that's about here. Nope. Yeah, whatever. It is what it is. Okay, so we'll call this X, Y, Z. What's the degree measure of every angle of an equilateral triangle?
60.
It is 60 degrees? Yeah. So every one of these angles is 60 degrees, and that's important. Because if I took a radius here, that would cut that into 30 degrees and 30 degrees. Now if I took another line and cut straight up here and I made that a right angle, an altitude, because it comes from the center and it cuts a chord, it's going to cut that chord in half. So that means that this is congruent to that. So all I need to do is find this side, and I have this entire side, which means I have this entire side, which means I have this entire side. So I must have more information. And so I'm going to reread it. If the radius of P is 6. So that means that this length right here is 6. This length right here is, well, if this is 30 degrees, that makes this 60 degrees. If I have a 30, 60, 90 triangle, do I only need one side?
Yeah.
Yeah, that's all I need. Okay, so that's about as far as I'm going to go. I'm going to let you look up 30, 60, 90, but is this good enough to start off with? All right, so that'll get you this side, that'll get you that, that'll get you all three of them. Okay? And if you get stuck working on it, like I said, I'm going to post the answer key online tonight. So if you're just like, okay, what did he do? I'll have it all on there. All right, other questions? 22. So 22 says Rn is 18. So this whole length here is 18. It says OQ is 12. It says OP is 10. And it says SM is some length. Okay. So what we need to do is, well, just in case this is necessary, that makes this 9. And it's going to make that guy 9. Right? Okay. What can I do next? Any suggestions? Mazen?
Make a triangle.
Make a triangle from where?
O to N.
O to N. So we make that triangle from O to N. And we get that value, right? Because we have 12 squared plus 9 squared. And so we get that. What measure did that come out to? There should be more than one person doing this. Unless you want me to walk around and check everyone's homework right now. Right?
Oh wait, which measure are we supposed to get?
Of that diagonal that Mazen just came up with. Because we could do that one, or we could do this one. Doesn't matter, it's be the same length.
Okay, I got, well, for the length, I got
15?
Yeah.
2. Yeah, this 225.
I thought you said it's like length met.
Oh, no, sorry.
Wait, is that right? That's right. That's how I got it. 225 squared.
I did a squared plus b squared equals c squared. Okay, what are we going to do with that length? Great. What was that? Mm-hmm. Is this not a radius?
Yes, it is.
This is a radius, so I can put it here, or I can put it here. We're trying to get S to M, so it really doesn't matter which one I do. You could put it right there. So that means I could put that guy right there. Doesn't matter which one I do, but if I put it here, that's going to give me 15, which once again, a squared plus b squared equals c squared will give me this. Multiply by 2 gets me that full length. Okay, other questions? Right? 21. So we have JF equals GF, so JF equals GF, and then it says they both equal 9. So that's 9, that guy's 9. It says EG equals 6. EG equals 6. Find LK. Well, if EG equals 6, that means GH equals 6. And it also means if these are equal distance away, if this is 12, that guy's 12 as well.
Okay.
Because equal distance, we have the theorem that two chords are equal distance, it means they're the exact same length. Okay, other questions? Quick. Don't hold on to them and raise your hand at the last second. Okay, then I'm going to move on. I will post the answer key with the solutions in case you didn't want to ask a question. It will be on there tonight. Okay, so let's go ahead. And this is a quick lesson. Just some huge concepts that will get you through all of that homework. It's just two big things. The first one says the line is perpendicular to the radius of a circle if and only if the line is tangent, or the line is a tangent line. So all they're saying right there is if I draw a circle. If I draw a circle, and I draw a line tangent to that circle. So that line is tangent. And I draw a line, or I draw a radius from the center to here. That automatically makes it a right triangle. Or not a right triangle, but a right angle. So let's give some names to stuff. Let's call this C. Let's call this E. Let's call this F. So that means CE, segment CE is perpendicular to line EF if and only if EF is tangent, whoa, this is getting sloppy, is tangent to that circle, what did I call it, C. So if I have a tangent line, where that line is, remember tangent means it only can hit once, so you don't have to pick between where it hits, it only hits once. So that point to the center is going to make a 90-degree angle. So even if this was a diameter, it's still 90 degrees. Whatever line you have, as long as it hits the center, that's going to make a 90-degree angle. Reminder, the tangent only hits once. Can't be a chord. Can't cut through, so it's just going to touch like that. All right, the other one says two segments drawn from the same circle that intersect outside the circle are congruent if and only if they are both tangent to the circle. So once again, we're going to draw a circle. This time we're going to draw two tangent segments. So we're going to pick 2 points where they're going to hit. So let's see if we can get this to work. I might have to erase something. Oh no, we'll be fine. See that duck I just created? It's pretty cool. Right? If I put 2 little eyes up there and a little... That's a duck. I'm going to erase the duck, right? All right. All this is saying is, let's call this A. Let's call this B. Let's call this C. Let's call this D. So, if this drawing is correct, that says that AB is congruent to CB. So if 2 lines are tangent, and they hit each other, or they intersect, those segments are congruent. So once again, let's put this in writing. Say segment AB is congruent to segment, what did I call it, BC. And I'm going to put a little notation in there. It's a double arrow. That stands for if and only if. So that's if and only if AB is congruent to BC, if and only if AB, segment AB, and segment BC are both tangent to circle D. I'm going to put some of that down. You just have crossing lines. All right, so AB is congruent to BC. That's a huge thing to know. It's going to be big in the homework. Both of these, because we only have 2 theorems. You better make sure you know them, because that's it. You just have these 2, and you're going to answer all those questions on the homework. I'm going to go ahead and skip to our 2 examples. So our 2 examples. Our first one says, well, if I know 36 degrees, find A. Well, I know this segment is congruent to that segment. That doesn't really help me much. But what I do also know is this line is tangent, and we have a line connecting the center. We're going to assume that's the center. If it's a drawing, we're going to assume it's the center unless I specifically say otherwise. So if that's true, that makes this a 90-degree angle. Well, the other one's tangent, and there's a line connecting the center, which means that's also 90 degrees. I have a 4-sided polynomial. How many degrees are inside a 4-sided polynomial, like a square, a rectangle, a rhombus? 360 degrees. So all you need to do to find A is just do 360, because that's how many degrees are inside there. Minus 90, minus 90 degrees, minus 36 degrees. And you're going to come out with 144 degrees. So A is going to equal 144 degrees, as long as you know that a 4-sided polynomial has 360 degrees. All right, our last one. Well, I can't create any right angles. The only time you can create a right angle is if I'm going from the center to the side. I'm not going from the center to the side, so this isn't 90. In fact, it's 48 degrees. So we're probably going to have to use the other theorem. The other theorem said if 2 lines are tangent and they intersect, that this segment is congruent to that segment. Well, if this segment is congruent to this segment, that means it's an isosceles triangle, which means our base angles are congruent. So this means this is 48 degrees. And it tells me that B is going to equal, who can find B for me? Right?
84 degrees.
Say that one more time.
84 degrees.
84 degrees. 84 degrees. I assume we did 180 minus 48 minus 48 to give me 84 degrees. All right, questions on either one of those two? All right, that's the bulk of what you're doing, and you're going to apply it to other things. So you will have to know like similar triangles, some other stuff that we've done before. I also want to look at number 4 really quick. Number 4. The big thing about number 4 is we have to recognize that that's a right angle. And the one above E is a right angle because they're tangent and they connect to the circle. If both of those are right angles, what does that mean about this line and this line? If they're both right angles. What does that say about this line? Not like length or anything. What does it say in particular about this line? Think way back. What does that mean if I create two right angles connecting those two? Sanji? They're parallel. Yep. So this line is going to be parallel to that line. That's an important key to that one because we have to think about alternate interior angles, same side interior, alternate exterior, whatever you want, whatever is needed. You need to know they're parallel to solve that one. All right, let's go ahead and get